Welcome to Technical Mentor channel. In this video, we are resuming our previous videos of filter design. In this video, we design a high-pass filter which eliminates the DC drifts of ECG but leaves ECG intact. Define the ideal pass frequency response and perform analytically an inverse Fourier transform to obtain the filter coefficients. Use appropriate window function. What is the functional frequency of an ECG? What is the minimum number of taps? Use my previous function which we designed in the previous video. If you want to see this function, please see the previous videos of this series that you developed in step 2 to filter the raw ECG signal. No high level MATLAB commands should be used, such as filter convolution not allowed. If you are not sure whether a particular function is allowed or not, please speak to me before using it. Your main program should be contain a loop which feeds the sample one by one into the filter as if the signal is echoed in real time after you have filtered ECG. Check that. So to solve this question, we see the theoretical work first of all. This is our theoretical work to solve the question. To remove a DC drift and 50 Hz noise, keeping other frequencies same at the same time. We need a single filter. We use following formula to get optimum number of taps. This is formula to get optimum number of taps. Fs over n is equal to 1 Hz. In this equation, m is number of taps. To get best ECG signal, we use following five different window functions such as Hanning, Hamming, rectangular, Blackman, triangular. To use these functions, follow these steps. Set all data into taps to 1. DC drifts and 50 Hz should be 0. Create 1 to 1001 matrix. Every value should be 0. Remove DC drift from tabs. Remove also mirror side DC drift. Remove 50 hertz from tabs. 50 hertz noise. This is noise. Remove mirror side 50 hertz. Using inverse fast Fourier transform to tabs to get impulses from tops. Reshuffling the impulse response, putting five different windows, function and loop function into signal. Create a table for comparing the results. Comparing the results. So we first of all we implement these techniques into MATLAB and see the result and then compare the result. I already done, therefore I have created everything. So we go to MATLAB. This is our global filter. So this is we do filter as a global variable filter coefficient representing impulse response. This is global filter coefficient is representing impulse response. Tabs we have to write a tab size such as in this I wrote 1000 creating 1 to 1001 matrix. Every value is equal to 1. Tab is equal to 1 should therefore we create this and we implement in the MATLAB. Okay. Removing DC drift. So we to remove DC drift in the tab matrix from one row to two column, value should be 0. Removing mirrored side DC drift. tabs is equal to 0. Removing 50 hertz noise. To remove 50 hertz noise, we use tab 45 plus 1, 55 plus 1 mean tab. This is tab variable tab matrix. In this matrix from 50, 45 and 46 to 55 variable should be 0. Removing mirror side 50 hertz noise tape is equal to tapes. This is tapes is for mirror side. Tapes is for mirror side as like 50 hertz noise removing. So we implement these techniques into MATLAB and create a figure. Plot tab. We plot tab. This is our tab. We plot tab, and this is our tab representation on MATLAB graph, and we labeling all the variables. You can see amplitude in the y direction, number of tabs in the x direction. Now we create circuit figure getting the impulse response using inverse Fourier transform. Now we apply inverse to Fourier transform on tab and plotting the response. Plot Hn impulse response output. Okay, you can see this is our impulse response output. Number of tabs. Here is the amplitude. Y label is amplitude. Now we reshuffle, create third figure and reshuffling h and 2 is equal to h and 2 1 to tab to size. We create h and 2 variable from ones to tabs over 2 mean tabs to half data hn tabs to half plus 1 half plus 1 plus 2. This is row data and this is column data tabs. So we implement this. Okay, now mirrored side. Now we apply mirror side into tabs 2 tabs 1 hn. Now plot the reshuffling data. You can see this is reshuffling data and labeling all the variables. See amplitude, number of tabs, output impulse mirror. Now we use Hanning techniques to use high filter design. So this is HN. We create HN3 variables and use Hanning technique. So we can see Hanning in the MATLAB. What is Hanning? Using help. This is a technique and our function which is using in this is function. This is MATLAB Bulletin function. This is MATLAB Bulletin function we use here. So we use Hanning. You can see and plot this in limited size 0 x limit should be 0 and 0.1 output for Hanning you can see. So we plot the response using Hanning technique. You can see pulse input output of Hanning window frequency. You can see this is output of Hanning window and This is y label finger vanning is agent 2 Henning tapes create vanning and filter. Okay, and Henning output and output my now we use my filter and EC data to for Henning implementation. Okay, error in my fill input sam to space index. What is error? Removed. So our output is this is our Henning output. This Henning output. This is Henning output, and then plot the Henning output with respect to time. You can see this is response title implement title here. So this is mhm, applying the Henning after filter. Now this is before filter. There are now we output we applying Henning after filter. So Henning output filter is equal to FFT. Now we apply a filter using Fourier transform on the Henning output and plot the F range frequency range. F is our frequency range in frequency domain and frequency response with Henning window technique. So we plot this. This is frequency response with Henning window technique. Okay, magnitude, and here is this is frequency. So this was our Henning technique. In the next video, we do same process and we use a Hamming technique in the next video because if I use all techniques, the video would be high. So thank you so much for watching this video. If you like my videos, please subscribe my channel. If you have any question, please ask in the comments. I will help you. Anything I will do. If you want code, please uh, comment. Ask your question in the comment. Thank you.